Okay, 5.4 sum and difference properties. They're called sum and difference because it's talking about, if we kind of just take a sneak peek down here, cosine of a plus b and sine of a plus b. And honestly, there are so many more identities that we're not teaching you. Okay, so it could be worse, I guess is what I'm saying. All right, so we're not going to prove this identity, but I do want to show you at least like what some people think is that you can distribute the cosine. You can't distribute cosine because it's not multiplying. How do we say this? Cosine of, not times, of. This is cosine of a plus b. It's not times. It's not times. It's of. All right, so you cannot distribute, and I'm gonna prove it to you by showing you what happens if you tried to distribute, okay? And this will be good. It'll review exact values. The semester exam's right around the corner, so this is a really good review. So first of all, we're gonna do cosine of a plus b. Now they give you a and b to be 30 and 90, and this is in degrees. So what is 30 plus 90? 120. Okay, so let's think about what quadrant is 120 in?
Quadrant 2.
Quadrant 2. So let's draw the triangle. Okay, and remember, this is 180 all the way here. This is the 120. So what's the reference angle down here?
The reference angle is 30.
Okay, so 120 gets me to this line right here. 180,
y equals to the first line.
it always starts right here. So 120, how much further from 120 to 180?
60 degrees.
60 degrees. So once you mark that as 60, across from the 60 is root 3. What's the other angle up here in the top? Sorry, what's the other angle? 30. I'm not going to write it because it kind of gets squished and it's not that big of a deal. But up here, there's a 30 degree, and so down here on this side, I'm going to write a 1, and then the hypotenuse is the 2. Okay, so cosine in this quadrant, all students take calculus. In the second quadrant, is cosine positive or negative?
Negative.
Negative, because what is positive in the second quadrant? Sine, right? All right, now we need to think about A over H. Okay, so the A adjacent would be 1, and the hypotenuse would be 2. So negative 1/2 is the answer to that part. Okay, let's see what happens if we take cosine individually of A, which would be cosine of 30, and then we add that to cosine of 90. Can you close the door? Thank you. Okay, cosine of 30. What quadrant would that be in? First quadrant. And they go ahead and give you the 30, so we'll mark that. Across from the 30 would be a 1. Root 3, 2. In the first quadrant, everything's positive. So cosine of 30 would be a positive what? Yeah, the ratio for cosine is still adjacent over hypotenuse, so root 3 over 2. If you're like, I have no idea what you're doing, you have got to come in for tutoring. It means you forgot a lot of stuff that we learned already. And a lot of this is going to be on the semester exam. So if you're just a little rusty on it, that's okay, that's normal. But if you're really not understanding any of this, please come in for tutoring. Okay, cosine of 90. This was one of our quadrantal angles. This was 0, 1. Which number do you look at for cosine? The first one. So we put a 0. Cosine of 90 would be 0. What is root 3 over 2 plus 0? Root 3 over 2. Now, did I get the same answer or different answers? I got different answers. They are not equal. So all of this to say, when you see a cosine of a plus b, it is not cosine of a plus cosine of b. We have to use actually a very longer formula. Okay, it's going to be a little bit more difficult. All right, and you actually have 4 because we have cosine of a plus b, we have cosine of a minus b, and then the same with sine. Now, look at how similar all 4 of these are. They're so similar. Wouldn't it be easy to get these mixed up? So aren't you glad you don't have to memorize them? Okay, so you got to either use your notes or use your blue formula card. It's on the back of that. Don't try to memorize these. You don't have to. And it's really, even I sometimes like get these mixed up. Okay, so the first time you're looking at them, you're going to get them mixed up. So just make sure you're always looking back at it. So when we're doing a problem, let's see, like example 2, all right, it says evaluate cosine of a plus b. Now I already know the answer is -1/2, by the way. I already did that earlier. But let's use the formula. Let's confirm that we get the same answer. So I have to use this formula right there. So cosine of a plus b is, I'm just going to write it down, cosine of a times cosine of b minus sine of a times sine of b. I just use this formula right here. Okay, now I need to plug 30 in for a, so this would be cosine of 30. And I need to plug 90 in for b. Now some of these I've actually already found, so I don't want to reinvent the wheel here. Like we already determined what cosine of 30 was, right? √3/2. Because it says it right here. Evaluate cosine of a plus b. Okay, we already did cosine of 30. We could redo it, but we already found out what it is. We already found out what cosine of 90 is. Okay, it's right from up here. 0. Okay, sine of 30. I'm just going to look at this picture. What's the ratio for sine? Opposite over hypotenuse, so back over here it'd be 1/2. And then I can look at this picture and say sine of 90, that should be the second number, which is 1. So we're using some stuff we hadn't done for a while. Okay, the simplification here isn't really that bad because what happens when you multiply something by 0? It goes away. And we have minus or -1/2 times 1, we get a -1/2. So notice this is the same. I got the same exact thing. Yay, that means the formula works.
So how did you cancel out the last part of your thing?
Because it's being multiplied by 0. And the 0 comes up quite a bit, which is nice because it makes simplifying easier.
Yep, equals smiley face.
Yep. So there's lots of different types of questions that could be asked using these properties. This is one of them. Okay, look at example 3. It's a little bit different. It already looks like one of the 4 formulas. Now I want you to look at the order of the cosines and the sines and the fact that there's a plus, and I want you to identify which of these 4 is this the same as.
Sine a plus b.
You're close. Which one is cosine, cosine plus sine, sine? Cosine A minus B. So I'm just going to go ahead and write that. I'm not going to try to keep everything in my head and then write it all down at the end. I'm just going to write down what I'm thinking. Now in this case, what number is A? 34. And what number is B? 20. Now that's always the case where the very first number you see is A and the second number is B. Okay, you can see that in the formulas, it works out that way. So let's plug that in. Let's plug in 34 in for A, and let's plug 20 in for B, and I can subtract those numbers. That's really not that hard to do without a calculator. I get 14. All right, so I haven't evaluated, but the directions just said I needed to simplify. So that's your answer. That big, long, messy thing is the same as cosine of 14 degrees. 14 is not a special right. It's not 30 and 60 and 45. In order to really evaluate what cosine of 14 was, I would need to use a calculator. Just for fun, for review of yesterday, because this is everybody's idea of fun. So for review of yesterday, what is the cofunction? How could I write a cofunction? First of all, what is the cofunction of cosine? It's right there in the name. Cosine, take off the co, you get sine. Now what number am I going to put on the inside?
14.
Not 14.
Oh.
The complement,
Yeah.
which would be 76. Now, this is also something I would need a calculator. Now, make sure you're in degree mode, but you could check that. Make sure you get the same answer. Okay, that's how you could check it. All right, so that was just review. I just threw that in for fun. Wasn't that fun?
Yeah.
Okay, so let's look at example 4. And here's another type of question. All right, so before I even look at this stuff, let's look at sine of A minus B. And this is where if you have your blue formula card out, it's nice because then you don't have to flip back and forth. But I want you to find the sine A minus B formula. And let's write that down. I don't want you to copy me. I want you to look it up yourself, and then you can kind of check with my work. Okay. So we got 4 things up there I need to find, right? Was I given any of these?
Sine A.
I'm given sine A. So I don't know cosine B. I don't know cosine A. I don't know sine B. So somehow this information right here is telling me all of that. So we have 2 different angles. So I'm going to draw 2 pictures. I'm going to draw a picture for A and a picture for B because they're different angles. Okay, so let's just first look at A. Okay, first of all, sine is positive 1/2 and cosine is positive, both positive. What quadrant is both sine and cosine positive?
First one.
The first one. Okay, so let's draw a triangle in the first quadrant. All right, and so here's my A right here. This says that sine of A is 1/2. That's opposite over hypotenuse. So the opposite of A is 1, and the hypotenuse is 2, which makes the missing side how much? Square root 3. Same stuff that we did before. This is just good review. All right. Now, the whole reason I did that is because I already knew what sine of A was, but now I need to know what cosine of A is. So what's cosine of A? Adjacent over hypotenuse, so root 3 over 2, and positive root 3 over 2. If you're worried about the negative, it's not that I put a negative there. The negative is coming from the formula, the minus in the formula. Okay, so now we're going to do the same thing with B. So we need to look at this, and we see, oh, tangent of B is positive, but sine of B is less than 0. So what quadrant is tangent positive, but sine negative? So in the second quadrant, sine is positive. The third quadrant, so all students take We're looking at for where tangent is positive 3/4 and sine is negative. This honestly is going to be the hardest part, I think, to this thing. And so now we're going to put a little b where our reference angle goes, and we're going to think back to what is the ratio for tangent? Opposite over adjacent. So I'm going to label the opposite with a 3 and the adjacent with a 4. And this is not a special right triangle, but it is a Pythagorean triple. Do you guys remember when the two sides are 4 and 3, what the hypotenuse has to be? 5. Let's say you didn't know that this was 5. You would have to go off to the side and just do a quick little Pythagorean theorem. That would give you 25. Okay? So you may have to go off to the side and do something like that, because it doesn't always work out to where it's a special right triangle or triple. Sometimes you have to do a little bit of work. Okay, so let's go back over here. Cosine of b. What's cosine of b? First of all, is cosine positive or negative in the third quadrant?
Negative.
Negative. So I'm going to put negative 4 over 5, adjacent over hypotenuse. Okay, and maybe put that in parentheses since there's a negative, so we don't misunderstand that that's minus or something. Okay, same thing here. So sine of b is also negative. We knew that because that's why we put it in that quadrant to begin with. And what would sine of b, what would the ratio be? 3 over 5, opposite over hypotenuse. Okay, we need to simplify this. So when you're multiplying fractions, this isn't really that bad. Look, 1 times negative 4. What is that? Negative 4. What's 2 times 5? 10. Multiplying fractions is easier than adding them. Okay, now I'm going to look at this. Minus times a negative. What's minus times a negative? Positive, plus. Okay, 3 root 3 over 2 times 5, which is 10. Now, if you do this right, you will always have the same denominator. See how they're both 10? If you don't do this right, they're not going to be the same, so that's kind of a good check. So here's your final answer.
Negative 1 square root 3.
Negative 4 plus 3 root 3 all over 10. Okay, so that was kind of a harder problem. There's a lot more to that. All right, so here's another type of problem we can do. All right, it says find the exact value. That means our answer should not, it's not just rewriting it. Like our answer should be numbers, exact value. But this is not, you know, we know exact values 30, 60, 45, 90. These are the exact values we know. But can you make 15 by either adding or subtracting any of these numbers? You have a couple of options here. Can you add or subtract any combination of these numbers to get 15? Yeah. I'm going to do 45 minus 30. Okay. We could have also done 60 minus 45. Now, this is a formula. Sine of A minus B. That's going to be sine of A, so sine of 45, times cosine B, so cosine of 30, minus cosine of A, times sine of B. Okay, I'm just using that sine of A minus B formula. We used that one earlier today even. And here A is 45 and B is 30. Okay, so we need to do each of these and simplify kind of like I did in the last problem. Okay, I'm going to be nice to you guys this time and we're going to split this up. Okay, all the girls on my left, you're doing, like girls over here, y'all are doing sine of 45. Boys, y'all are doing cosine of 30. Okay, over here, girls are doing cosine of 45, boys are doing sine of 30. So if you're like, I'm not sure where to go, draw draw something like this and start from there. All right, you can do it. Okay, girls, what'd you get? Sine of 45.
Pi over 4.
1 over square root 2.
So 1 over square root 2. Did anybody simplify it to root 2 over 2?
Oh,
Okay, that's fine. I'm going to leave it with that. 1 over root 2. That's what I would have done. Okay, guys, cosine 30. Root 3 over 2. Okay, girls over here, cosine of 45. 1 over root 2. And sine of 30, guys. 1/2. Smooth. All right, so let's multiply. 1 times root 3, that's root 3. When you're writing something like this, write the number that's not a square root in front of the number that is a square root. Okay, and here I just have a minus, so I'll just write the minus. 1 times 1, that's 1. And again, I'm going to put the 2 in front of the square root of 2. See how the denominators are the same? That's always going to happen. It's pretty nice. So you don't have to worry about getting a common denominator. You just need to do something like that. Root 3 minus 1. You can't combine those, by the way. Over 2 root 2. That's your answer. It's messy. It's gross. It's maybe not your idea of fun. But that's the same as sine of 15. You guys ready to do this again?
Yep.
Okay, here's the good news. If you remember your other properties, you get out of lots of work. So can anybody tell me what sine and cosine, how are they related to each other? I'm looking for blank functions. Co-functions. Sine and cosine. It's in the name. They're co-functions. Are these angles complements? Meaning, do they add up to 90? Yes. So what is cosine of 75? The exact same thing. Don't do all the work. Just use the property.
Wait,
I can. Because sine and cosine are co-functions, and 15 degrees and 75 degrees are complementary angles, sine of 15 is cosine of 75. So like on yesterday's homework, I might have given you sine of 15 and I said, hey, write a co-function. Rewrite this as a co-function. So if you recognize that, you get out of work.
Wait, how are sine and cosine?
So it's in the name. Here's, if we write it out, if we write them out, this is how they are not abbreviated. Sine and cosine. So it's like in the name, those are the co-functions. It's also on your formula card though. You can refer back to that. Okay. C. Sine and cosecant. How are sine and cosecant related? They're reciprocals. So do you see how the angle's the same? This is not co-functions I'm talking about anymore. It's reciprocals. So what I just need to do is flip it upside down. Okay? So I just need to do 2 root 2 on top and root 3 minus 1 on bottom. That's your answer. That's all you have to do. If you know the properties and you look for them, you look them up, you really don't have to do that much work on these.
That would be the same answer as sequence, correct?
Yeah, this would be the same as secant of what? Not 15,
75.
75.
Oh, well, the secant of 13.
That would be a different problem. We'd have to kind of start over. It'd have a lot of similarities, but I can't do that one. All right.
Okay, so when you're reciprocals, you have to be the same.
Right. The only time you do complementary is when you're doing co-functions. All right, let's look at example 6. We got to do this proof. Y'all ready? One proof and we're done for the day. Okay, definitely going to start on the left. Ooh, looks like some sum and difference formulas. Sine of A plus B. What's so funny? Are y'all laughing because I go, ew?
you and you looked over there and Graham was like, wait, she looking at me?
Oh, no. No.
Like,
Sorry.
what I thought too.
Okay. No, I'm just looking around. I'm seeing who's paying attention. Okay. So look up the sine of A plus B formula. Okay, everybody look this up on their own. You can turn back in your notes to the front, or you can look it up on the blue formula card, either way. But sine of A plus B is going to be sine of A, which is x, times cosine of B, which is pi over 6, and then a minus or a plus? Plus. Cosine of A, which is cosine x, and then sine of B. So sine of pi over 6. Now everything I wrote is just for this first one. Okay, so I'm going to write a big plus, and now I'm going to come over here and do this one. So which formula am I looking up now? Cosine of A plus B. So we got to look up that formula. I am totally serious. So cosine of A, so cosine of x, cosine of B. I'm not doing this off memory. I'm looking it up. Like beside this, I have the formulas right here. You need to be having that blue card out or your notes out the whole time.
It's a really long formula.
We're looking for cosine of A plus B formula. And so what would come next, a plus or a minus? Look, I'm looking at this formula. We don't need to write all this down every time, but it's cosine of A, cosine of B, minus sine of A, sine of B. I'm looking at that formula. So I need to do minus sine of x, sine of pi over 3. Okay, see everywhere there's a pi over 6, I can evaluate that. What is pi over 6 in degrees? 30. Okay, I will tell you, by the end of the year, I want you to be able to look at that and go, the answer is blah. Okay, we're not there yet. Right now we're still learning it. By the end of the year, before you leave this class, you are going to be able to do this in your head really fast. All right, but for right now, we're not there yet. We need to actually probably draw the triangle, put the 30, across is the 1, hypotenuse is 2, root 3. So what would cosine of 30 be? Yep, so what would that be in this triangle? Root 3 over 2. Okay, then we have cosine x, and what's sine of pi over 6? 1 over 2. Okay, good. Okay, we're going to do the same thing here. Cosine of pi over 3. So I'm just going to change this drawing up. And what is pi over 3 the same as? 60. So now the across is root 3. Hypotenuse is still 2, and 1 is down here. So what would cosine of 60 become? 1/2. I got to keep this lesson rolling or y'all are going to fall asleep on me. Okay, so what I want you to notice is there anything that looks like it's going to cancel? Something maybe that's positive and then you see the same thing, but it's negative. Yeah, look, right here. Sine x times root 3 over 2 and minus sine x times root 3 over 2. All right, now we have cosine x times 1/2 plus cosine x times 1/2. Just for fun, I'm going to rewrite this where the half is in front, and I think it will, these are not canceling because they're both positive. But what's half an apple plus half an apple? A whole apple. So what's half a cosine plus half a cosine? 1 whole cosine. And look at that. That's what we were trying to prove. There you go. So this is a proof where it's knowing what to do isn't that hard. It's the doing it. Like normally in proofs, knowing what to do is the hard part.
I have no idea.
All right, I don't know